Imagine you're a teacher with a classroom full of students learning to solve math problems. You start by giving them a set of problems along with the correct answers. The students study these examples, learning the patterns and techniques needed to get to the right answer. After enough practice, they should be able to solve new problems on their own. This is the essence of supervised learning in the context of machine learning. In supervised learning, a machine learning algorithm is like a diligent student. It learns from labeled data, which means each example in the training set comes with an answer, just like a math problem set with solutions. These labeled examples are crucial because they guide the algorithm in understanding how to make predictions or classifications. Let's break it down further with a practical analogy. Imagine you're an up-and-coming chef learning to cook. Your mentor gives you a series of recipes, the training data, each with a detailed list of ingredients and step-by-step instructions, or features, and a photo of the final dish, a label. Over time, by following these recipes, you learn to recognize which ingredients and techniques produce a certain dish. Eventually, you become good enough to create new dishes without explicit instructions, based on what you've learned. Translating this back to machine learning, supervised learning involves algorithms that can be trained on data where the outcome is already known. There are two main types of supervised learning tasks: classification and regression. Classification is like sorting your inbox into spam and not spam. The algorithm learns from a set of emails labeled as spam or not spam, and then predicts the category of new, unseen emails. It's like teaching the algorithm to distinguish between different kinds of objects, such as photos of cats versus dogs, or medical images indicating healthy tissue versus tumors. On the other hand, regression is about predicting a continuous value. Think of it like estimating the price of a house based on features such as location, size, and number of bedrooms. The algorithm learns from past data, where the house prices are known, and then predicts prices for new houses. It's kind of like predicting the temperature for next week based on historical weather data. The process of supervised learning can be broken down into a few key steps. First, gather a large set of labeled data. For example, if you're building a facial recognition system, you need thousands of photos with tags identifying who is in each photo. Next, feed this data into the machine learning algorithm. The algorithm uses this data to learn the relationships between the features, or input, and the labels, or output. This learning process involves adjusting internal parameters to minimize errors in its prediction. It's like adjusting the ingredients in a recipe until the dish tastes just right. After training, test the algorithm on a separate set of data that it hasn't seen before. This step checks how well the algorithm generalizes to new, unseen data. If your cooking skills are good, you should be able to prepare a dish correctly even if it's slightly different from the ones you've practiced with. Finally, measure the algorithm's performance using metrics such as accuracy, precision, recall, or mean squared error for regression. If the performance isn't good, you might need to tweak the algorithm, get more data, or refine the features. It's like fine-tuning a recipe after tasting it. Supervised learning is powerful and widely used because it leverages the guidance provided by labeled data to make accurate predictions. However, it's obviously not without its drawbacks. Obtaining labeled data can be expensive and time-consuming, and the algorithm's performance heavily depends on the quality and quantity of the training data. In our tech-savvy world, supervised learning applications are everywhere. When Netflix recommends movies based on your viewing history, it's likely using supervised learning. When your smartphone's voice assistant understands and responds to your commands, that's supervised learning. Even fraud detection systems in banks use supervised learning to identify suspicious transactions based on patterns learned from historical data. In conclusion, supervised learning is like teaching a student or a chef through examples with clear outcomes. The algorithm learns from labeled data, mastering the relationship between inputs and outputs to make accurate predictions or classifications. Whether it's sorting emails, predicting house prices, or recommending movies, supervised learning plays a crucial role in the AI systems we interact with every day.